If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new topic in basic level, that is differentiability. So in this lecture we will see what is the definition of derivative, differentiation, and how we say that a function is differentiable at a particular point A. Okay, then let's see this. Okay, so the topic is differentiation and differentiability. Mostly it is differentiability. Differentiation, just we will see what is differentiation. And when differentiation is possible, then we will say it is differentiable, or that is the ability to differentiation is differentiability. So we will not go in details of differentiation here, that we will see in later topic, that is method of differentiation, and then we will see application of differentiation. But here the idea of differentiation, what is the definition of derivative? Derivative and differentiation both meaning is same. So first we have to understand some things. Suppose delta is a very small number, it can be positive or negative, that we have considered. And x plus delta is the neighborhood of the x. X is suppose a point, and in a point which is not fixed, x. So x plus delta or minus plus delta, because delta can be negative also, so it can go this side also. So a very close to x is known as the neighborhood of the x. It's not neighborhood that you can go here and say it is neighborhood. No, although it is showing very big delta, delta is not that much big, because you will see delta is a very small number, as small as you can think of 0.00001, 0.000000001, whatever you think, whatever small value you can think. So that is known as the neighborhood of the x, either side. Fx is continuous at the neighborhood of the x, and this is also given that fx is continuous. That means you can draw this curve. Once you can draw this curve, then it comes to differentiation. Then what is the definition of differentiation? F dash differentiation can be also symbol is f dash. F dash means it is one time differentiation of fx, or the symbol is d dx, d by dx or d dx we say of the function fx. So you are differentiating the function of fx with respect to x. That is also required. What with respect to what? That means with respect to x means you are moving in which direction, x direction or y direction. This is x means you are moving in x direction. So the idea is, the definition is limit delta tends to 0 fx plus delta minus fx by delta. So if I take delta for now, this side, delta can be this side also. So this is delta, so this position is x plus delta, although it is magnified, but it is very close to each other, as close as you can think of, very close. But for understanding I am doing it in little separation. So this is the x plus delta, here the output is fx, here the output is fx plus delta. So fx plus delta minus fx will give you this one, and delta is this one. So it is nothing but you can see the slope of this line, slope of this triangle. So if it is very close, then it's become actually the tangent. So this is one of the application of derivative. We will see there are lots of applications. So that's why one application is known as to find the tangent of a curve, you do the differentiation. That is one of its prominent applications. So this limit delta tends to 0, because delta is very close number. Now from here itself, this limit should exist. Now for existence there will be left and right hand, and it should be finite. So from that only the differentiability concept came. That means whether the function is differentiable or not, whether this limit is existing or not. Now if you want to go very specific, suppose I want to take a derivative at x equal to x0. Here it was loosely for any value of x. Now it is particularly for x equal to x0. So you will replace this x by x0. So from this position you will move a little bit either this side or this side. That is x plus delta. If you will move a little bit x, what is the change in y? That is also known as rate of change of one variable with respect to another variable, another application of derivative. That means another way you can look this graph. If you change x, how much change is y is there? For little change in x delta, how much change in y it is? So that is the rate of change of one variable with respect to another variable. You are changing x, that's why it is differentiation with respect to x. So that is the idea. Now if you are going to very specific x equal to x0, the definition becomes this. At that point f dash x0 is f x0 plus h, you move a little bit from that point either direction, minus original one. So you got the change in the y divided by what change you have done in your x-axis, that is your delta, that is your variable with respect to whom you are differentiating, provided that the limits exist, and it should be finite. Exist means only the finite, because infinite limit doesn't exist. Now from that the two things concept, because the delta I have drawn in the right side only, this delta I could have drawn in the left side only also. So that's why, like your left hand limit, right hand limit, one new concept, new definition came, left hand derivative, right hand derivative. What is right hand derivative? That is LHD, RHD, like your LHL, RHL. If you define LHD and RHD, so before that you will have to take fx is continuous in the neighborhood of x equal to a. Suppose the point I am considering x equal to a, this is the point, and h is a very small positive number. Now h is very small positive, you have to be careful, it is positive. So what is RHD? RHD is f dash a plus. Normally we write f dash a, f dash x0, but if I write f dash a plus, that means I am seeing right side of a. So I am moving little bit a in the right side. So it is h I have moved, although I have shown is very large, but it is very small. But for your understanding I am showing it is a plus h. So this position is fa, this position value is fa plus h. So if you draw this one, it is the second of a, right second, because you are drawing the right second through a, through this point. So what is fa plus h? This length is fa plus h, this length is fa. So fa plus h minus fa is this, divided by h is this. So you are actually calculating this theta, tan theta, this by this. That is slope of right tangent. What is the slope of this tangent? This by this. What is this? Total length fa plus h minus this length fa divided by this h. So this is the slope of right second actually, provided that this limit should exist, then only you will say the value of RHD is this. If limit doesn't exist, then you don't have any RHD. Similarly, if you go for LHD, you need to move in this direction because h is positive. Now it will be a minus h. I am moving this direction. I write it f dash a minus h tends to 0, f of a minus h, it is this one, minus f of a, this length divided by h. That is minus h actually, not h, because you are moving in this direction, that's why it is minus h. So you can see this length f of a is this, f of a minus. So if you take subtraction, you will get negative of this one. So minus minus get cancelled. Ultimately you got this one. So this is the slope of left second. You make this correction in your notes. Slope of this is the left second. This is the second that you have drawn through a. That again provided that limit should exist at finite. Now if h is very close to a. Now if you are making it as small as possible. So suppose if you are reducing h. So if you reduce your h, your b will come here. Then your b will come here. So ultimately your this AB will, from second it will become a tangent. Because it will move, if you come b here, so it will move in this direction. If you move b here, so it will be here. If you move b here, it will be here. So you can see your del theta 1 is reducing. Ultimately if you move as close as to a, it will be look like this tangent 80. So gradually if you reduce it, it will give you this tangent 80, which is known as right tangent. You are drawing tangent in the right direction. So if h is tends to 0, as h gradually decreases, then RHD will give the slope of the right tangent 80 with a slope of that theta 1, with a slope angle theta 1 at the point A. Similarly, if you reduce this one, if you C is here, then this is here. If you C is here, so ultimately it will come to 80 dash if you come to very close to A. So as h is tends to 0 or h is gradually decreasing, your LHD will give the slope of the left tangent, that is 80 dash with slope theta 2 at the point A. Now to check differentiability, now when we will say it is differentiable at x equal to a at a particular point. First the function should be continuous. This has to be satisfied. Without this you cannot proceed. If it is not continuous, then no need to go further. It is not differentiable because you need to draw at point A. If you are not able to draw, then no need to, you cannot take differentiation. Now at x equal to, you calculate your LHD and RHD like this way, or differentiation. Then if it will be differentiable at x equal to a. At x equal to a, you calculate LHD RHD. If both are equal, then only you will say it is differentiable at x equal to. So your LHD RHD both should be equal. You calculate these two, and if they should be equal, then they are like your LHL RHL. Then we say limit exists. Here also, if limit exists, then only differentiation exists. So this limit is known as derivative. Limits of this limit is done for to get the derivative. That's why it is named as derivative. Ultimately, it is the limit only. Then it is differentiable at a. So this is the condition of differentiability from here to here. It should be continuous. LHD and RHD, they should be equal and finite, obviously. Otherwise, limit does not exist even. Geometrically, what does it mean if these two are equal? Geometrically, this means you can see if you come here also, this if this was coming very close to this, then this angle was theta 2. This was theta 1. If it is coming very close, then ultimately theta 2. Geometrically, if theta 1, theta 2 are same, that means it is the same line. AT and AT dash, both are same line, making same slope. That means you are drawing a unique tangent at the point A if both are equal. Otherwise there will be two tangents at the A, one in right side, one in left side. If both are equal, then it is the same tangent. So geometrically theta 1 means it will be theta 1 equal to theta 2, implies that AT dash and AT both are same line. So that means at point x equal to A, that means at A point you can draw a unique tangent. We have a unique tangent, that is T dash AT. This line is the same line. They all are collinear, they are lying on the same line. So that is the meaning of differentiable function, means you can draw a unique tangent at that point. Now that means if I say a function is differentiable, that means it has obviously passed continuous test, that's why it can came here, that's why it was differentiable. So if I say it is differentiable, the function has a differentiability, that means it must be having continuity, that's why it is having differentiability. But if I say it is continuous, then it is not implying that it is differentiable, because the second condition cannot be also satisfied. So even if it is continuous, it cannot be differentiable. But if it is differentiable, if you are coming here, that means you must have cleared this exam, that's why you clear. Like you have cleared class 10 exam, that's why you can come to class 12. So if you are passing class 12, that implies that obviously you have passed class 10. But if you have passed class 10, that doesn't imply that you have passed class 12. Non-differentiability doesn't imply discontinuous. So if I say it is not differentiable, you have not passed class 12, you have failed in class 12, that doesn't mean you have failed in class 10 also. Because if you are not differentiable, it can be of this cause also. You cannot say it is discontinuous. It can be continuous, still it is not holding true, that's why it is not differentiable. But if it is discontinuous, if you are not passing class 10, then it means obviously you have not passed class 12. Because if you are not passing class 10, how can you appear for 12? So if it is not discontinuous, then obviously it is not differentiable, because you cannot come for 1. So these things you understand very clearly. If you like the video, then press the like button and please give your valuable comments in the comment section.